Okay, so now we're going to talk about forces between charges. Okay, so there are forces between the different charges. For example, if your hair has accumulated a positive charge, then each of your hairs on your head, each of the hairs is positively charged, and those positively charged hairs, the same charge, positive and positive, will repel. So all the hairs end up standing up on end because they don't. They repel each other, and that means that the hairs that are standing up towards the top of your head, if they fall down to either side, they're coming closer to another positively charged hair, and they get repelled back upwards. So the fact that the same charge repels means that all the hairs stand up on end. So if we take two positively charged acetate rods, put them next to each other, dangling from bits of string here, those two rods are going to repel each other. We're going to see them pushing ever so slightly apart to each side. So they repel each other. Okay, so the correct physics terminology is repel. So what happens if we replace one of these rods with a polythene rod? Remember, polythene gets negatively charged. Okay, so here we have a negatively charged acetate, positively charged polythene rod, positive and a negative charge, they attract. Opposite charges attract. Okay, polythene positive, acetate negative, they attract. Okay, so the same charges, positive, positive, repel, negative, 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 repel, but opposite charges, positive and negative, they attract. So, for example, here we've got two spheres which we can charge. For example, this one's negative, this one's negative, they repel. This one positive, they repel. Positive and negative, they attract, and if we swip them around, negative, positive, they attract. So in your Google Doc, you've got this table to note down, to pop a tick in what happens when each of these spheres are positive, 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 negative, negative, positive, negative, negative. Put a tick in the boxes. I've given you a tick in the question, so you just have to copy and paste the tick into the correct space. Now, we've got all sorts of demonstrations that we can do with static charge. The most famous one is the good old balloon and the wall. So what I'd like you to do is in your Google Doc is to note down the explanation using the correct physics terminology of each of these demonstrations of static electricity, okay, and explain why it's happening. So here we've got a balloon and we've got a jumper to charge it. So let's rub the balloon against the jumper there until we've built up a charge on the balloon. Built up a negative charge on the balloon. Now inside the wall there's electrons and there's the nucleus of the atoms, which is positive. So when I bring the balloon close to the surface of the wall, I push some of the negative charge in the wall deeper inside the wall. So that leaves the surface of the wall positively charged. The negative on the charge on the balloon attracts the positive charge on the surface of the wall, and they stick. The balloon sticks to the wall. They're attracted. Okay, and that's because the negative charge moves deeper in the wall. Let's charge her up again. I bring the balloon close to the cat, which is a bit nasty. So, negatively charged balloon. What happens again is negative charges go deeper inside the cat's body because it's liquid, and nerves and stuff, and the cat can conduct electrical charge. So electric charge in the hair, the negative charge moves deeper into the body of the cat, further down, because it's repelled from the balloon, and the tip of the hair becomes positively charged, and therefore is attracted to the negatively charged balloon. Ta-da! Bits of paper. So, again, in the bits of paper, negative charge moves down to the bottom part of the piece of paper. The top part of the piece of paper therefore becomes positively charged and is attracted to the negatively charged balloon. And by far the most fun one is the fact that charges can move inside the water. So negative charge moves to the opposite side of the water, of the what do you call the drip? It's not a drip, but a stream of water. So negative charge moves to the opposite side. That leaves the surface of the water close to the balloon positively charged. It gets attracted to the balloon, and we see the path of the water is diverted. It's moving towards the balloon because it's attracted. So there's some fun examples of the forces between charges.